Hi everyone, and welcome to the flipped instructional session for 4.04, Speed and Velocity. So be sure to take notes during this recording, and remember you can use those notes on your unit test and submit them for extra credit afterwards. All right, as we get into the lesson, let's go ahead and get started. So speed and velocity, you've talked a little bit about both of those and the difference. So let's look at this example. An Olympic athlete runs a 400-meter race around a track, winning in just under 44 seconds. His average speed was 9 meters per second. That's more than 20 miles per hour. And yet, at the end of the race, his average velocity was 0. How can this be? What is speed anyway, and what is velocity? So in this lesson, we'll find out exactly what these two words mean, as well as how to calculate the speed and velocity of any moving object. All right, so here's the student guide. Remember, these are optional. You do not have to submit them to me. So if you are behind, that is something you could skip over. So we already have a good idea of what speed means. And remember, you want this definition in your notes. It's a rate of motion measured as distance divided by time. And that is the distance divided by the time required to travel that distance. So I encourage you to write down the formula for speed. Distance over time, we measure distance in meters and time in seconds, and that is going to be something you will start using often. Some things move fast at a high rate of speed and others move slowly at a low rate of speed. Scientists define average speed as the distance an object travels divided by the time it takes to travel that distance. For example, a peregrine falcon that takes 1 second to dive 50 meters through the air has an average speed of 50 meters per second. A ball that falls 9.8 meters in 1 second has an average speed of 9.8 meters per second. Speed takes into account both the distance traveled and the time it takes to get there. Select the pictures to see objects with varying speeds. So here you can take a look at things like race cars and jaguars. So all kinds of things there for you to look at. You do have a graphic organizer. Again, you are not required to complete it, but if it does help you organize speed and velocity, I do encourage you to do it. You do come across definitions, formulas, sample problems, and you can use that graphic organizer as part of your notes to help you differentiate between speed and velocity. So something that is very helpful, but again, not required to be submitted for grading. So if we're looking at calculating average speed, to calculate the average speed of an object, you divide the total distance as it is traveled by the time it takes to travel that distance. So again, we're using this formula, distance over time. In the formula, S represents speed, D represents total distance, and T represents total time. So if you walk 4 miles in 2 hours, D equals 4 miles and T equals 2 hours. So you could also calculate your speed this way. So here you're able to see that. And again, you want those formulas and sample problems in your notes. All right, so as we look at this simulation, you'll observe how long it takes for a ball to travel 1 meter after rolling down the ramp. Take a ball from the toolbar and place it behind the starting line on the ramp and release the ball and observe the timer. Then you can reset the timer and take at least 2 more measurements to make sure you're getting accurate readings on the timer. So this is an activity you can do. You're starting and you're seeing how long did it take until we're looking at the timer, 0.69 seconds. So we reset. putting it behind the starting line. Again, you always test it 3 times, right? Oh, did we not reset it? I don't think we did. All right, so again, you could go through and answer the questions and see what you could do to change the speed of the ball a little bit, and what ways will you discover. So that's a fun simulation to just kind of check how the variables affect the speed. So here's some practice problems for you. Again, I always encourage you to put these in your notes. You will see them on quizzes and tests, so looking back, knowing how to work them is important. So a cheetah has a top speed of 31 meters per second or approximately 70 miles per hour. Suppose that during a hunt, a cheetah runs 700 meters in 35 seconds before catching its prey. You can calculate the cheetah's average speed by using this formula. So you can see that worked out here. The cheetah's average speed during the hunt was 20 meters per second, or roughly 45 miles per hour. So if you can look, miles per hour is something we recognize here in the US. Obviously, you could convert meters per second into miles per hour doing the math conversions, or you can leave them, which is what we normally do in science, at meters per second. So just recognize that those are different, and if you see that pop up on a quiz or a test, make sure you're looking at the difference. So during the chase, the cheetah would have run much faster at times and at others much slower, such as when it had to change direction to make its catch. So now you'll solve these problems using the formula again. So when it talks about average time, it means it's taking into account for the slowing down and speeding back up. So here are some ways that you can practice and see how you do. Velocity, we know, is the rate at an object's move in a certain direction. Velocity is always represented as a direction in relation to a reference point. For example, a car driving east might have a velocity of 50 kilometers per hour east. So you always need to see that directional point. In the example you just saw, Sarah ran 400 meters in 80 seconds. Her average speed was 5 meters per second, but what about her average velocity? So it depends on where she ended up compared to where she started. If she ran 400 meters on a straight path north, her average velocity was 5 meters per second north. If she ran 200 meters on a straight path and then ran back 200 meters straight back to her starting point, her velocity would be 0. So this is kind of like we discussed in a live session recently about displacement. So look at the example here. Even if these balls are traveling at the same speed, each one has a different velocity because it's traveling in a different direction. To calculate the average velocity, you need to know where the object started, the point where it ended, and how long it took to get there. So this is another formula you need in your notes. Average velocity is represented by the formula V, velocity, equals change in the starting point, is that where it is? Position, yes, change in position and change in time. All right, so we're looking at the change in the position or the displacement, and then the change in the time. So you can look at the example of the cars on the track, and if one of the cars starts and ends at the same point in the race, making a loop, what is the car's displacement? And we know if it starts in the same place, it is 0. Starts and ends. All right, so here are some more practice problems calculating velocity. All right, so more practice calculating both. So it is important to read through these and be able to determine which one you're looking for and answer those questions. Good practice looking at the answer choices and determining what the question's asking. So don't skip those. Here you're practicing, you're choosing the formula that you're going to use to solve the problem. So this is a great practice to see, 1, if you have the formulas written down, and 2, if you know how to use them. Interpreting data. So to calculate the average speed or average velocity, you need data. Sometimes you'll have a lot of data, and the best way to manage it is to put it in a table like the one shown here. You can use this data to calculate average speed or average velocity by using the appropriate formula. So again, more practice here. At 0.0 meters and 0.0 seconds, what is the average speed and the average velocity? So our answer there, both would be 0 because there is no change in distance, displacement, or time. So here's another practice problem and an answer, and another here too. So you can kind of check yourself and see if you're getting those. Now you have to look at the graph or the chart, data table, and answer the question. So practice going through those as well. This lesson has quite a few parts, so we want to make sure we're going pretty quickly to get through all these. So vacation time, are we there yet? Do you remember asking that question when you were younger? Now you can answer that question yourself, but to do so, you need data. Specifically, you need to know the distance between two travel points and the average speed of the car. In this activity, you will calculate the average speeds for the different trips throughout the continental United States. All right, so here is the investigation data table part. So it talks about creating a data table. Again, the purpose of it is to collect information and use those measurements for comparison. You can do that in a spreadsheet. That's actually a kind of data table. This is where you can put in your column headings based on the information and the measurements you wish to collect. The rows will then be used to list the items you are collecting and the information or the measurements about. And so this just gives an example of video rental stores, which is something we don't have anymore. Distance in miles, how far they are away, speed limit, and calculating the driving time. So remember that idea of the summer vacation road trip is a great way to look at and solve problems dealing with average speed. So how do you calculate average speed? If you remember, we're using the formula distance over time. So here are the speeds that you're getting. You've got 717 miles from New York City, New York, to Columbia, South Carolina. It takes 12.5 hours to make this trip without stops. So what's the average speed? So again, you're looking here and you've got to divide the distance over time, and you're able to...
It is 717 miles from New York City, New York.
I don't know if you can hear it start talking.
Columbia, South Carolina. It takes 12.5 hours to make this trip without stops. What is the average speed?
All right, so it's just reading you the problem if you didn't see that. So again, you can calculate there and find the formula you're going to use, put the numbers in, and then do the math. All right, so as we go on to the next part of the lesson, the procedure, this is asking you to do something here. You will use the map resources to find the distance in miles between cities, and then using the data collected in the data table, you'll calculate the average speed. So you want to review and follow these steps to answer your question. All right, so 1, collect your materials. You have an internet site or a road atlas of the U.S. 2, you can refer to the assignment worksheet to build your data chart. 3, you can look up the distance between each pair of cities in the data chart using an internet site or a road atlas. And you can even ask your phone or your little Alexa or Google device. Step 4 says use the driving time listed in the data chart and the distance information you recorded to determine the average speed for each trip. Record that value in the data table. And then finally, complete the assignment by answering the questions. All right, so we've got this map. What would happen to the average speed from Reno to Tulsa if you increased your driving time to 30 hours? So you would have to look up and figure out if we're going 26 miles and we increase it to 30, the average speed would decrease by 57.83 miles per hour. So you would have to know the distance between those two cities. So you would have to look that up. So same here for Portland to Cincinnati. And you're using what formula? Again, distance over time. All right, so is it speed or velocity? You'll answer the questions here, being able to tell by the clues given. And checking your knowledge. You've had a chance to use your knowledge of speed and velocity to answer questions and solve problems in real-world applications. Now try this one. The posted speed limit for a trip to the corner store is 25 miles per hour. There are no traffic lights or stop signs on the 2.5-mile route. You arrive at the store in 0.05 hours. You brag about this to your best friend, who is impressed but tells you that you're lucky you weren't arrested. Why? So if you were to figure out the distance over time, you'll know that you were going 50 miles an hour, which is twice the speed limit. All right, so that is the end of the lesson. And if we go back up here, just to show you guys what this looks like again, we've gone through all of these. It does ask you, you're talking about the vacation. It shows you a data table. It gives you a procedure. There is not a worksheet to complete on this. There's nothing to submit. It's kind of worded a little bit tricky. So you're not going to be turning anything in. Just practicing pulling that data. So if you have time to do it, great. If not, just click through and read. Or while watching this recording, that is all you have to do for the lesson. So have a great day.